All right.
Thank you
And
so
now the
much.
recording is in progress. Thanks, Richard. Thanks, Joanna. Really appreciate you inviting me here to talk. So I am Matt Christie. I am a director for TRC, working in energy efficiency and net zero buildings and electrification practices. And so this is a slide deck that I developed for a local organization called Building Science and Beers, which is a loose affiliation of builders and energy geeks who are interested in this. Talking every once a month on a Thursday in Salt Hill about building science and top energy technologies. And the content of this deck is stuff that I'm working on professionally at my company at TRC, born from a few developments, some of it with NYSERDA, the New York State Agency on Energy and Research, some of it from work I'm doing in California and other places. All of it geared at trying to help homes electrify, right? What are the barriers? What are the breakdowns? And this talk is all about one specific breakdown, which is the electrical capacity or electrical constraints of the home itself when trying to add heat pumps. So I'm going to go through this, and we'll have time at the end for questions and answers as well. All right. So here's the goal. This is what in my profession, what I'm trying to accomplish for every single home in America as fast as I possibly can through my clients, which are utilities and state agencies, right? The fully electrified home, right? You got rooftop solar providing some of the power yourself. You've got heat pumps doing all of your HVAC, so high efficiency electric, all sorts of different types of heat pumps. Could be ground source, air to water, but heat pumps managing your heating, battery storage system to help you blend, high efficiency washers and electric dryers, no propane or natural gas dryers, induction cooktops, high efficiency lighting, heat pump water heaters, an electric vehicle or two in the garage, and then of course your panel managing your house. So this is what we're trying to get to. And I'm working in all these technologies. The challenge is when you start putting all those technologies in a house, you have to power them with electricity, right? Which can be done, but you're pulling your electricity from the grid. Most people, there are a few people that are offline as well, which have a different constraints and different challenges that we can get into. I know a lot of people in the local region are entirely off grid. I live in South Stratford. I've got some neighbors that are off grid, but those that are on the grid, you're pulling your electricity from the power system from your local utility and you're bringing it into your home. And that connection point creates a pinch point, right, of energy transfer that you have to make sure you can pull in enough energy out of the grid and bring it into your home to power all of those appliances and devices. So some of the terms we're going to get working with, obviously there's the utility pole. That's what's bringing your power to you. There's a transformer periodically along the poles. That's a voltage drop. It takes a high voltage electricity or medium voltage, frankly, that courses through those local lines, turns it into low voltage before sending it to your house. It does that through a service drop, which is the line that goes from the main pole, from the transformer to your house. There's a weatherhead, which is sort of where it enters the house. Sometimes this is underground. That's not always in the air, but you have this or a version of this somewhere when you're tapping into the grid. That energy then goes through the service meter. That's your energy meter, your meter outside on the house that measures how much is passing through it. And then that also sources through an electric panel, which then distributes that energy through electrical circuits all throughout the house, serving all of your needs. That's the setup and structure. Let's talk about ownership. Who owns what in that system, right? In that confluence. So in the utility owns the poles, the utility owns the transformer, the utility owns the service drop and the connection point, and the utility owns the electric meter. And then you, the homeowner, or whoever, the landlord who owns the building, owns everything else. They own the actual weatherhead and the drip loop, the stuff that connects it, the cabling, the ground rod, the entrance cable, the actual meter can, the actual panel on the other side. So the utility is responsible for all this stuff, and you're responsible for all that stuff. And this comes into play where I'm going to get into. And then what's really limiting your power is the amount of electricity that can flow across this service drop wire, right? This is a single point of entry, which is then paired with the amount of power that your meter can then pull in and distribute. For most houses, those two items match. But for some houses, there's a mismatch. And in that case, whichever is lower is the fundamental limiting factor. Grid edge homes, like out by out in the way back, very, very old homes and cabins might be on 50 amps or 60 amps of service. This is called your electric service limit. And that is a measurement of one of multiple different types of measurement of how much power can flow across this wire and flow through your panel. Older houses might have 100 amps. That was very, very common up until the 90s or 80s, depending on where you lived. And then newer houses are all on 200, 300, 400 service, right? Most are on 200 amps these days, but bigger houses will be on 300 or 400. And then a commercial entity might be in way higher than that, 800 more, right? And then they even get into three-phase power and other things we're not going to talk about. But if you're in one of these older houses, 100 amps, they're very common around here. It doesn't have to be grid edge. And they haven't been upgraded. Some older houses have been upgraded and gotten a new service line since. But if you're on one of those, there's your main constraint. Another related constraint is from the utility itself. This is obviously a map of Vermont because the data is easy to get because they publish it nice and pretty, and I live in Vermont, so I pulled it. And this is just a random day that data published, a random day of Green Mountain Power's actual power lines, and which ones are constrained and which ones have plenty of room to take on more load, can let more electricity flow through them. And you'll see there'll be pockets that are grid constrained. And those are locations where the poles, the meters, right, everything else they're funneling as much energy as they can right now, right? Because basically it's about the thickness of the copper coming down the line, and the existence of the transformers and the power of the substations, which are those little, electricity looking things that are speckled here and there that you kind of breeze past in your car, don't really recognize as anything meaningful. But those are managing power flows from the big power lines to the lower grade local service power lines. And sometimes you get to a spot where there's a pinch point. I live in Stratford. We're in a pinch point commonly because the energy line that has to come up Route 132 from Sharon, or the line that comes from Thetford, those are the only two ways in or out. And they have a limited amount. And if one goes down, you're in real trouble. They got to have redundancy in the power grid. So you have these spots that are grid constrained themselves. And it may be difficult to get more amperage to your house from the utility in those cases, right? If you're on one of these low amperage homes and you want more, you may call your utility and they may say, no, I can't, right? I'm too constrained there. Or I can, but it's going to take me a year or longer to pull that off. There's also delays and challenges, like if they have to upgrade a transformer, if they have to upgrade a substation, or just getting to you time-wise. Like they prioritize other activities, and sometimes it might take a long time in a queue to get a service upgrade. The next thing in your house is your electric panel, right? That's the other place the energy all flows. After it goes through your meter, it goes to your panel. It all goes through a main breaker. That's this little black thing at the top here, right? That's rated 160 amps, 50, 100, 200, right? Hopefully matching your service drop, but not always. In most cases it is. And then that is split up into lots of circuits, right? The plugs and appliances go out to specific circuits doing various parts of your home, right? So there'll be generalized circuits for your lights and the sockets you plug your computers and your TVs and your hair dryers into. There'll be other circuits for individual appliances like an electric stove or a washer dryer set. And those will typically be a 240 volt, a bigger power draw, right, that you plug in. Maybe if you have an electric water heater, it'll have its own circuit. So bigger appliances will have their own dedicated circuit, and then general appliances will have their own. And I saw a question in the chat. Yes, we'll make this deck available to anyone. I'll send it out to Joanna as a PowerPoint, and we'll figure out how to make that available to you. And I think we're recording as well. I'm sure there'll be a way to figure that out to make it available to people. All right. So the key of this entire game is that the sum of loads, right? If you turn on your washer, your dryer, all your lights, your hair washer, your heat pump water heater, your EV charger, all the things that are connected all at once, and they're all asking for power, the sum of those parts, if it exceeds the amount of electricity that can come over your wire and through your panel, you have a problem, right? The main problem is if you do that for too long, without intervention, you'll heat up the wire, you can cause fires. Now, luckily, we have circuit breakers that stop that, right? If you're doing it for too long, and by too long, I mean like over 20 seconds, 30 seconds kind of range, the breaker will pop. And you've all experienced this with some circuit in your house at some time in your life, or most likely all of you have experienced this, where a breaker will pop. That's an individual circuit, right? That circuit had something go wrong with it, a fault or an error, and it popped. Your entire main breaker can pop as well if the sum of all of that comes across. So that could pop the main breaker, turning off power to your entire house. You can turn it back on, but you want to avoid that ever happening. So the National Electric Code has a whole process to help, figure that out, which I'm going to go into in a little bit. And as I was kind of just discussing, the issue is coincident peaks. And that term means, is just, I have lots of things going all at once. Right, so this is data from my house coming off of my power wall. I have a Tesla battery. And this is just 2 random days in March last couple of years ago. And you'll notice on the left, notice the scale. This scale over here is 2.7 kilowatts is the top of the bar. And my house is bopping along, right? These are things, lights are turning on and someone goes to the bathroom, someone turns on the toaster, someone does this, does that, right? The house is just being used and it bops around between 1 kilowatt baseline and 2 kilowatts or so, right? With little spikes as things turn on and turn off. And it just does this all day. No big deal. This day, 2 days prior to that, notice the scale has changed, right? This is now a top up of 8.3 kilowatts. And my house is still bopping along at 1 for most of the time with spikes and peaks. But then right around 8 a.m., it has this huge run for like 3 straight hours. That's laundry day. That's my dryer. Straight up, right? I use my electric dryer for a couple cycles in a row. You can even see the cycles happening, and it pulls a lot of power at once, right? And you can have fun with this. I can have my kids turn things on and be like, okay, what happens when I turn on the toaster? Look at the app. Boom, right? Certain appliances, hair dryers, really high power power plugins. But the electric dryer is a big pull. Now, I will point out that this seems like a big pull, but in terms of my home, this at the top here, that's about 16 amps. So I'm not even close to 100 amps of draw, right? That safety limit I'm talking about. Not even close. I'm not even in the ballpark. Here's a friend of mine's house, different tool. This is being measured with a Sense, which is a energy measuring device you can connect to your panel. And same deal. Here's his house churning along. Notice this is now at 25,000 watts, so 25 kilowatts, much bigger scale than the last one, which went from 2.3 to 8.3. This is at 25. So his house is pulling, I don't know, we'll call that 2 or 3 most of the time. And then boom, these huge runs of big draws. He's got an F-150. He's got the electric F-150, right? Or the E-Lite or E-Lite or whatever they're calling it. He's got a big electric vehicle truck. Plugs it in, pulls 40 amps at a time, right? Just goes, big draw. And it pops up. So if this big draw happened at the same time that you did a dryer going, at the same time you had this going and that going, you could really add up and you can get closer to that limit. And so this whole thing is about, delaying that safety limit. Here's a different day, right? Same thing, churning along, EV charging going on at night right here. So the way that the electric code helps keep us safe and keep our houses from burning down is the electrician is hired to do the job and to follow the electric code's rules. They take a tool, there's dozens of them out there, and they basically just add up your loads. And there's a formula and a system of what loads get added at what value. And I'm not going to go into the nuances of the NEC calculation, but Section 220.82 is for residential homes. And you basically go through and you're like, okay, I have one general lighting circuit. I have one blower fan. I have one this says parking lot lights because it looks like this is a commercial one rather than a residential, but same principle applies, right? I have a water heater. I have a stove. You plug in all of your things and the system does the math. And it basically says, And it's not actually if all of them fire, it kind of has some hedges, right? It knows that not everything's ever going to happen exactly at once. But if lots of things happen at once, how much in danger am I? And the math is such that if you're on a 100 amp service, if your 220.82 worksheet comes out as over 80 amps of possible coincident load, or likely-ish, kind of mostly possible coincident load, then they'll say you need a bigger service. We can't plug those things in. We can't run that much electricity through this panel. You're going to run too hot at some point, and we're too worried about fires for that. So got to get a service upgrade. And then if you're on 200 amps, it's 80%, so 160 if you're on a 200 amp service. And so they give you that little, they have that little wiggle room sitting right there already for if you cross over it for a little bit and come back down. But so 80 amps is the safety factor for a 100 amp home, 160 amps for a 200 amp home. And you can do the math on the other ones. So here's the problem statement, right? Which is pretty obvious at this point. I've been teeing it up, I hope. The challenge, we're trying to electrify all these homes. And if you're going to electrify homes, right, is if you're trying to get a service upgrade, it might cost you between $3,000 to $30,000 to go from 100 amps to 200 amps, right? That's to get a new panel, get it installed, get a new service drop. And the 3,000 is extremely cheap for this. Right? It's very rare to get that that cheap. That means you have a overhead line, the transformer is close to you, the service drop can just be swapped out, the utility can get scheduled to do that quickly, and then your panel can be replaced, which is about $1,000 for the panel and $2,000 for the labor. And it's all really easy because the wiring was simple. Your old panel was well organized. You could just kind of swap it out nice and fast without as much effort. The breakers can be reused, all that stuff. Very rare. Most of these are talking in the $6,000 to $10,000 range. But then if you start talking trenching, if you've got underground service drop coming in, 30,000, lots and lots of money can get piled in really quickly. The other thing that I talked about earlier is you might also just be delayed, right? You might not be able to get this service upgrade. You might call Liberty or Unitil or Green Mountain Power in my case, and they may say, sure, give me 7 months. And you're like, but I just bought the EV. I want to use it now, right? And you didn't think of this, right? Or, I don't want to wait that long to do this heat pump upgrade, right? My furnace blew out and I need to swap now. So what do I do? You also have the issues that if all these homes all over the place are doing this all at once or near each other, is you might start overloading the grid level too. So one house getting a 200 amp upgrade, whatever. 10 houses, 100 houses, right? There's a limit where eventually the utility has to go, oh, okay, now we got to do a transformer upgrade, a substation upgrade, a line upgrade. And then it's a much bigger. Now cost isn't going to fall on you directly, but it's going to fall on us communally through your rate basing it and coming through your electric payments eventually. And it will also mean delays, right? Again, I can't get you that upgrade because that line is too constrained. Hold off 2 years, please. So here's the proposed solution. And I'm running a demonstration pilot on this in upstate New York in the Finger Lakes area. It's still underway. We don't have data yet to share. So this is talking about the concept of what that demonstration pilot is about. But the solution, the proposed solution is that through a combination of active load management technologies, which I'm going to go into what that means, we can hold electrified homes under those safety limits of 100 amp service and avoid the upgrade entirely. So let's get into what that means. Active load management, right? It means what it says, right? I am going to take that energy load and actively do things to say, don't break 80 amps, right? Don't cross that threshold, and prevent it from crossing that threshold with some brains, with some smarts, or with the types of appliances that I put in. So I'll go into each one of these, and we'll go into detail on a couple of them. Induction stoves. I have an induction stove. I love it. Boils faster, great technology, cleaner, easy to clean up, safer. Right? No gases in my house. Turns down precision control on the heating, but they draw a lot of power when you turn the oven on. Just as much power as an old stove because it's just electric resistance in the oven. Induction on the top, electric resistance in the oven. If I'm baking a turkey or if I'm putting a pizza in, I got to preheat to 475. That's a ton of energy draw. Big pull. You'll notice it on your chart if you have one of those. The battery assisted ones, there's a couple of companies offering these now, Impulse Labs and Channing Copper. They're both very new to the market, and others are trying to follow suit. But they're both very much on the premium expensive side, but the battery does qualify for tax credits under 25C. Regardless, what they're using is they have a battery built into the oven itself, right? Kind of in that underbelly where you store spare pans. There's a large battery or medium battery down there, like 3 kilowatt hours, 3 to 5, I think, is the ones they're using. And what they'll do is in those high draw, which is basically the preheat or like boil mode, right? When it's pulling a lot, is instead of pulling that from the grid, they'll pull that from its own battery. So these things you can plug into a normal socket, 120 volt socket. You don't need to get a specialized 240 volt socket installed. Plugs into a normal socket and they can run, and they never draw above what that socket pulls. So their energy draw, they don't have that spike, right? They'll pull off their battery, they won't spike. They'll pull more than if they're not using it, and then they'll refill the battery when you're done cooking. Or even they'll refill the battery while the oven is just just holding its heat, right? It's gotten to preheat, it's just holding at 350. It doesn't take a lot of it. It only has to fire back on once in a while to maintain that temp. Along the same ilk, I'm going to go through the appliances first and then get through the fun circuit level stuff. 120 volt heat pump water heaters. So these are versions of heat pump water heaters, again, that also plug into a regular socket. The 240 volt ones to draw more power. These things run at like 3 amps. They're so much lower. Now, they're also the little engine that could, right? They churn slow. Like heat pump water heaters already have that reality, right? They produce hot water slow and steady. And they don't have big catch up, right? They jump into an electric resistance mode when they want to catch up because you've had 4 showers in a row. You've had a long water draw. So these things are not for every household. But if there's a retired couple or someone living alone or a small apartment or even a small family that's willing to be smart with their water usage, they're great, right? They heat up plenty. They have an 80-gallon, 50-gallon, 60-gallon tank of hot water. When they are drawn down or drawn a little bit low, they pull a lot less power from the grid at one point of time, and they have a much lower impact on your NEC calculation. So Rheem has these, Nile has these. There's a few others in the market right now selling 120 volt heat pump water heaters. Next up, clothes dryers. My example, my spike was my clothes dryers. Electric clothes dryers use a lot of energy. Heat pump clothes dryers use about a third at their peak. They run for longer periods of time, right? A dry cycle on these takes about 3 hours instead of maybe 45 minutes because it's drawing it out. But they're recycling their own heat, and they're using heat pump technology to, on the cold side, to condense water out of the air stream. So they blow warm air. They heat up the air with the heat pump. Not super hot. It's a much more mild air temperature. They blow that warm air through the drum. They take that moisture-laden warm air and they put it to the cold side of the heat pump. Remember, heat pumps have a hot side and a cold side. They run that warm, moisture-laden air over the cold side, and the water condenses right out and drips out of your dryer. And then it does it again, runs that air back through. Does that over and over again. A couple benefits to these: because they run on lower temperature, they're not as harsh on clothes. You can dry wools in them and they won't shrink. You have way less lint. They're just less damage to clothes, right? It's low heat temperature. They also don't need a vent. You could put these without a vent going outside, right? Because they're not actually venting any hot air. All the heat is being recirculated back through the system to do that cycle. So you don't need a vent whatsoever. That also helps you on your air sealing of your house because you have one less penetration coming into your house. So if you're trying to have a really nice tight house, that helps. It also means you can kind of put them in more places in your house. You still need the water hookup, right? Because it takes the water, it condenses out, and it drains it out of the same water hookup that the washer does. The other thing that's fun is many of them are sold as washer dryer combos. One machine. You put in your laundry once, you hit go, you come back 4 hours later, it's totally done. Cleaned and dried, one machine. Takes up less space in your laundry room or your closet or wherever you have them. So I actually switched over to one of these about a year ago, which means my data is no longer possible in my house, and I've been quite happy with it. Next up, circuit splitters. These, time check. All right, I can speed up a little bit. Circuit splitters. These take 2 240 volt loads and put them through one socket. So there'll be a 240-volt socket behind this, and I plug two different things into it. And what the circuit splitter basically says is thou shalt not be used at the same time as each other, ever, right? Common is two EV chargers, right? And it'll basically say it'll charge car one and then it'll charge car two, and it will never charge both. So you'll never get stacks of that. Another common one is a dryer plus one of these, right? Or a stove plus an EV. Right. And so like my dryer and my EV, I can't charge my EV when I'm doing a dryer load. Okay, that's fine. Right. And then when the dryer load ends, it switches over on its own, right? You don't have to do anything. It has all the smarts built in. So it knows which one. It says dryer has priority. He hit go on dryer. I'm going to dry. I'm going to turn off the EV for a bit, and then I'm going to swap back when the dryer load's done, then charge the car overnight. So you can do this to kind of pull two loads and put them onto one circuit that will never fire the full volume. So that could save you like 20 amps, 30 amps right there. Boom. Even 40 or 50 amps. Meter collars, similar. These things tie in outside of your panel on your electric meter. They kind of tap into the power supply right as it comes in after it gets measured by the meter before it goes to your panel inside. And electricity comes off of that. And that gets you sort of on the outside of the system. At the same time, it is measuring how much flow is coming through the main service drop line or the connection line. And if it's ever getting hot over 80 amps or up towards the 80 amp limit or whatever limit is set for that building, it'll cut off whatever it's feeding. So these are often used to feed electric vehicles. These are often used to pull in power from solar to avoid having a breaker, a safety breaker on the meter side if you have solar power being pulled in. But technically they could be used to supply or provide a dryer or a stove, but it's kind of an inconvenient place. So EV is the most common, but similarly, right, they could be kind of outside your calculation. One of your main loads or a big load can be sort of outside of that, summing up to 80. And then new, this one's just is very new. Mitsubishi has a series of heat pumps that can be throttled back. So instead of turning these, and I'm going to tell you in the next slide what controls this, but basically instead of saying turn off, like all these ones, circuit splitters, it's like go or no go, turn off or turn on, meter collar, go or no go. These ones will basically say, okay, I'm running hot, turn down 10%. Still hot? All right, 20%. All right, 30%. And they'll kind of throttle back in 10-degree increments down to about 40. And then they say, okay, now we'll just cut it. And that can be used as a way to throttle back without inconveniencing any other loads that you're pulling from. All right, so those are your tools in your toolkit here for staying under 80 amps. Now, the other thing you can do is obviously just upgrade your service, right? So there's two different flavors of this. One is I added them all up and they don't add up to 80, but I don't have enough breaker spaces in my panel. I've run out of space, right? I don't have enough slots. That's allowed. You just put on a sub panel, right? So if you need a whole bunch, like a handful of breaker spaces, add a sub panel. Basically, this is just an appendage. It's like extra slots that you can add on. It costs some money. You got to get it installed, and electrician has to check it out and everything else, obviously. But 1,000, 2,000, I don't know how much I want to quote for electricians, but you get that panel installed. If you just need like one more space, thin double pole breakers or tandem breakers, you can split one circuit and still be safe, because sometimes there's circuits that take up 2 slots but really didn't need to, and you can split off of those. The electricians will know which ones you can do that with, and you might have a solution where I can get away without adding a sub panel. If you need just a little bit more capacity, right? So that's the tandem breakers, thin double pro, as I talked to before, the circuit splitting, the smart breakers. Oh, I didn't say that one in the last slide. Smart breakers. A smart breaker is one of these breakers will have brains to say I'm running hot. It's kind of like what I talked about with the meter collars, right? It's metering, it's measuring how much energy is coming through the whole panel at any given time. It knows that it's the first one to call it quits, to sort of cry uncle and stop. It says, okay, the house is running hot. I'm done. I'm going to pause for a bit. I'm going to stop running energy through me. And it can save you the need for that upgrade. put in a couple smart breakers on your dryer and your stove and your EV charger, or you might be able to pull that off. The other one is a smart panel, which is basically an entire panel filled with smart breakers, and it manages each individual little load one at a time. It has a priority list. It'll say, okay, I'm running hot, turn down this one first. Still hot, turn down that one. Span is the company that can communicate with those Mitsubishi G-Series heat pumps to turn them down. But I know that Mitsubishi is working with some of these other vendors to try to build similar arrangements over time. Right now, Span's the only one that I know that can do that. And it has to be the G-Series as well. So that's a sort of a newish world of data connections. And then, of course, if you need a lot more capacity, like you're not even close, all right, then we may need to talk about going up to a service upgrade. But that's where you have to deal with the cost of that, and especially if you have buried wires. What we're trying to show is that most homes, where are we in the, there's a study in California that we looked at like, 400 homes, different climate, right? These homes had heat pumps though. These homes had all sorts of electric uses. And over the course of a year, something like 40% of the homes never crossed 30 amps, ever. Not a single minute of the day, not once. Right, some of them got up to 60 or 70 amps. The charts that I showed you before of my house, right, the max of my house when it was running full speed with those was like 16 amps or 20 amps or something like that. That's the most I ever drew and I went back. I have 3 heat pumps running in my house. I have an EV charger. I have an electric stove and an induction stove without the battery assistance. I have all these things. I look back the entirety of the winter. I never had a single day that pulled more. Now that I've gotten rid of my electric dryer, I never had a single day that went over 8 amps. Sorry, 8 kilowatts. So 16 amps. Close means 80 amps, right? That's the threshold. If you're on 100 amp service, 80 amps is the most you can ever pull coincident before being dangerous, right? So we do the math on that spreadsheet. It adds up. It says, all right, you're close, you might. But then you actually operate the house, and it's like, it said I might get to 80 amps, but that has literally never happened. I didn't even get near that. I got to 10 amps. I got to 15 amps as the max of an entire year. Like, why do I need a service upgrade to 200 just because I'm adding like a 30 amp, I'm adding an EV charger of 30 or 40 amps, right? I'm never going to get there. I know your math is telling me that I will, but I won't. So we're going to talk about that in a second as well. So some of these technologies to curb it, and then there's one other method as well. But before I get there, when you are doing this planning, like you're thinking about electrifying your home, plan ahead for the full thing, right? If you're going to bring an electrician to your house to plan things out, know what your end goal is and be thinking about that ahead of time, right? Do the NEC calculation, thinking about, all right, this year I'm putting in heat pumps, but I plan to get an EV in a couple of years because that's important to me. I want to get off of my gas car, and it's, I got about 1.5 years left of useful life in it, right? I know I want to switch to an induction stove. I know I want to switch to a heat pump water heater. Bring the electrician in and have them figure out the wiring side of this and the service capacity aspects of this early. Know what your limits are, because then you can plan around them, right? They do the math. They're like, you're going to be in trouble. You're a 100 amp home. I'm calculating your full plan is up to 160. What are we going to do? And that's when you say, okay, I'm going to look into those battery assisted. I'm going to look into the circuit splitters. I'm going to look into these other options, or I'm going to get in the queue now to get the service upgrade so that I can get it as quickly as I can. And it's not like when I buy that final appliance is when I'm really in trouble. I can do these first upgrades now and then do that later, right? Plan that all out ahead of time. Another option for managing this is to use the alternative calculation in the NEC 220.87. The other one was 0.82. What 0.87 allows you to do is to basically say, I'm going to measure how much power my house has used. Now, you need to have available AMI, like advanced metering infrastructure. So basically, you need a smart meter or some other device that is, there's a list that's allowed, but some other device to collect your data for one full year, measure it out, and then say, okay, look at the reality of my house. And then you add on the new loads. And if that times 125% doesn't exceed the limit you're talking about, the code says you're good to go. So you might get some of these circuit splitters on your first appliance and then start doing the data when you have those things installed, right? And do this work ahead of time. Be ready for your sort of measurement period with the house at a certain state, and then be able to add those final bigger loads, biggest loads that might have crossed you over the threshold. So if you did the math early, you talked to your electrician that came up with 170 amps or something, and you're 100 amp home, you say, okay, I'm gonna do circuit splitter, I'm gonna split these two. I'm gonna do 120 volt, I'm gonna do water heater, I'm gonna do that smaller. Then I'm gonna measure, and then I'm gonna add the EV charger last. Because I've measured it, it didn't cross the threshold, and I'm good to go. There is a 30-day measurement period, but there's some adjustments that they force on that to kind of boost it for seasonal equipment. And these are the ways that you can manage electrification of your home without necessarily going the distance of a service upgrade. And that's my presentation.
Matt, thank you so much for an excellent presentation. I think what you are presenting here is really important, especially to those of us who are asking people to, in the interest of getting away from fossil fuels, we're encouraging people to electrify, and we just seem to be adding more and more loads to the grid. And the fact that you are showing us these various options, I think it's so valuable, and that's why I wanted to do this this talk.
And I'll stress a little bit, like some of the stuff is new, right? The electrician you call may have never heard of a circuit splitter, right? I called an electrician to get a circuit splitter put in my dad's house in Grafton, no idea. I went, okay, I'm going to call a different electrician, right? So some of this 220.87, some electricians have never used it, don't know what's in the code, or maybe they know it, but they're not familiar with it. They choose not to use it. Some authorities having jurisdictions, that's your permitting agency that's saying, yes, you can do this. They may not have heard of it, or they may not be comfortable with it. They may need some talking, some information, right? To say, this is normal, this is allowed, it's in the code, you can accept this too. Right. So some of the stuff is new enough that it's not like necessarily like, oh yeah, just do this, this, and this, easy as pie. Right. Some of this stuff is a bit of a challenge. I'm not going to, deny that, or, but it's building steam and momentum. More evidence is coming. Right. So we're running a pilot in New York with span panels and all these technologies. We're going to run it for the next year and produce in upstate New York heat pumps, heated homes, fully electrified, to show that this works in practice, and take that data to bring it into the market to show electricians and permitting agencies and everyone else that this is possible and viable.
Yeah. I want to say just one more thing, and then we're going to open it up for questions, and I'll explain how we'll do the question thing. The other thing that I really got out of your talk is that these energy monitoring devices like Sense or Emporia, or you have something from your Tesla Powerwall, that I want to encourage people to spread that news, that those are really valuable tools for anyone to have in their house, because it will let you know exactly how much you're using at any time. Okay.
There have been some questions in the chat as well that we could roll through in addition to
I
hand
see
raise.
that. So let me just explain how I'd like to try to do the questions, and we'd like to encourage people to use the raise hand feature, which is, hold on, I'm gonna change something. To use the raise hand feature, if you take your mouse or your cursor to the bottom of the page, and you find, where the heck is it? Oh, the React tools. And there's a little button there that says raise hand, and it will put you at the top of the little picture list, and we'll know that you're ready to ask a question. And then just don't forget to unmute yourself when you're ready to talk or called on. And I don't know, people are putting questions in the chat, so we'll try to get to those or monitor those as well. And there was a little technological glitch. Some people, we have multiple Bill Schmidts, so maybe you could identify yourself when you come on. So Matt, do you want to call on people?
Yeah, and it's doing prior. So Greg has the first hand up. So Greg, go ahead.
Yeah, I'm curious about how Powerwall might work. Instead of, you mentioned the battery and an induction stove. If you had a whole house kind of replacement for a generator, how does that affect this whole equation? Can you pull from that to reduce your overall load?
Yeah, current generation Powerwalls don't have a programming capability to do this yet, but they will. They're working on it. So it's not in the available technology sphere right now today with current Powerwalls. But it might be a software upgrade in the future, or it might be a product upgrade in the future. The team that built Span is ex-Tesla Powerwall engineers that switched over to build it in a panel. So this is known to Tesla. They're going to get there, and with Schneider and the other battery companies. But right now, there's not a technology that can do basically that reactive, that sort of active load management of like, I'm going to go take care of this load for a bit to keep the service low. But it's coming. I have no idea how long. All right, Bill Schmidt with the 37 words icon.
Yeah, hi, my name's Sherry. I don't know why it says Bill Schmidt. I've never seen this before.
There are like 8 people named Bill Schmidt because something Joanna did with the registration mechanism by accident. So we have like 8 Bill Schmidts.
I'm wondering if you could give an example of a meter collar. I know Green Mountain Power has a pretty new program offering something called the Connect DER connector that looks like the picture you showed.
Yep, Connect DER is a prominent company doing smart meter.
Is anything like that available in New Hampshire?
Yeah.
Where would one get that?
You could go to Connect DER. It's their website, right? It's a product. So
okay, but are there others besides them, or is it too new?
There are. I'm blanking on any brand names right now, though. But if you Google meter collar, or again, though, this is one where not all meter collars have smarts built in. Some of the early ones were mostly for solar connection to PV tie-ins. But Connect DER is the first one that I knew of, that I had heard of, that does like EV charging version. But I've heard of others. My brain is blanking right now on what their brand names are.
Okay, great. Thank you.
Matt, maybe you could answer a couple questions from the chat.
Sure.
Because they didn't know about the raise hand thing.
Yeah, so Greg already asked his. Sloan is saying, can you use these technologies for a new home that does not have historical data? So for a new home, you wouldn't be able to do the measured. You could use these technologies for sure, right? But then you'd have to find a way to convince the electrician and the HJ. Basically, you'd have to go through the 220.82 method and show that your loads are being controlled. And that's one where like the jurisdictional approval process, you might run into some folks like, I don't buy it yet, right? So it is tricky to do with new construction. I'll do one more from the chat and then we'll switch to hands. Induction stove, does it use more current than a regular resistance stove? No, exact same thing. Well, I guess where it does is if you are running your oven on preheat and multiple elements on top, stovetop elements at like high power, like boil level, that might be a higher spike than just electric resistance tops and stove on preheat. Because that's got a power boost thing. But that in that one instance, for that like one moment, you're trying to get your oven ready and you're boiling pasta on 3 different burners at once. All right, moving over to Richard Thompson.
Yeah, can you hear me okay?
Yes.
Yes, you can.
Yeah, so my situation was that I have a 100 amp service underground and all that. So I opted and I wanted to get, well, I got an EV. I wanted to put in 2 heat pumps and, ultimately get a second EV. But my solution was to put in a critical load panel that then was hooked into a battery backup and solar. And I put that in a couple of years ago, and so far, so good, where there seems to be enough solar to keep the batteries running. And in worst case scenario, the inverter is tied to the grid, so I could tap into that. But the idea was to, avoid that service upgrade.
Yep.
So I didn't know, you hadn't mentioned that option, so I just wanted to point that out.
Yeah, thank you. That's definitely a functional method that I didn't layer in.
Yeah.
All right. I think the Barry Woods form of Bill Schmidt with a nice sign up. So thanks, Barry.
Hey, Matt, thanks for this. Listen, I appreciate your experience here. I've got a situation where I've got a 200 amp service. I've got a 5 heat pumps coming, an EV charger, and a hot tub. Electrician wants to upgrade it to 400 because it came in on her load analysis at 250. And what I'm trying to figure out is it's a 300-foot conduit run. It's going to cost me like $24K.
Yeah.
I'm really trying to avoid that if there's a way to do it. And what would you recommend generally in terms of like thinking about this? Would a smart panel, because it's just 2 of us, we don't, it's not a busy household. I'm just curious what your recommendation might be to help load manage this.
I mean, a smart panel is the ultimate control device, right? The span panel will definitely keep you under that limit easily. If you're able to delay things, you could have her go through to 20.87, and you probably find out pretty quickly you're not anywhere near that 250 that the 220.82 calculated. Your reality is probably 120 at most, even with all that stuff going at once. It's a little tricky in your case because those things aren't installed yet, right? So, right, you've got a lot coming in all at once. So like, can you defer one component of that, measure it for 30 days on the 30-day allowance, add in the final load, something like that might be possible. But yeah, that's where I would go. The other one is like, depending on what you're connecting, circuit splitters, right? If you have a couple things that you can do to split something into two different, because that can, you're 40 amps over, right? Actually, I guess you're a little bit more. If you're coming up with you're at 200 amps, she's mathing out to 240. You got to cut 80 amps off that. That's a lot. That's a lot to cut. So yeah, you might be able to do that with some circuit splitters to pull off, especially the EV charger. You're probably running that at 50 or 60 on its own as its own circuit line. So that if you get that one on a circuit splitter or on a smart breaker to never fire unless we're on a meter collar, that's your biggest one to cut off is like one go. And then you want to think through everything else I talked about and what's in your system with your electrician to figure out what else you maybe can curb down.
Do they just a real quick follow-up, do they do a load analysis with that smart panel? The attributes of that, is that how they end up doing the calculation?
So here's one of the places where this gets tricky about kind of acceptance at the permitting level versus reality of the danger of fire. And so SPAN as a whole team that is dedicated to helping authorities having jurisdiction recognize and understand that with that panel installed, you're never going to cross the limit. You literally can't. It won't let you. Right? You would program in 160 amps, the safety threshold for a 200 amp service, and your house would never cross 100. You cannot do it. The tech's going to prevent it. So that's why it's the ultimate arbiter that does that. Now, how successful would they be with your town's approvals, I don't know, right? That's why we're running demonstration pilots. Why we're trying to do this, to just get more data, get more information to show the world that, to get past those pinch points on the sort of approval regulatory side that still exist.
Just to intervene just for a sec, someone in the chat is suggesting to Barry that you can cut the EV charger down to 30 amp or 40 amp.
It's
There
true.
are ways to control that, and using a splitter for the EV charger and the hot tub might help.
Yeah, the hot tub's the other big target to split off. Put on that one on a smart breaker, put the EV on a smart breaker. Yeah. Or a
And
splitter.
Matt, maybe you could answer, there's a question here from one of our Bill Schmitz. Should electricians be worried about liability using these new technologies? For example, circuit splitters. Can circuit splitters solve most capacity issues involving EV charging and multiple heat pumps? Would that be the first tech solution you'd look at in lieu of an upgrade?
Yeah, I mean, that's where I went. My dad's got a cabin in Grafton. He's trying to get an EV charger so that I can go there and charge up. And my sister can too when we're visiting, and 100 amps, and he's out of space, right? So I'm using a circuit splitter for that one. I do think that's the first go-to in terms of price. Like NeoCharge is who I bought, and it's something like $300 or so. Right, and when you're doing it with a dryer splitter, you could do that yourself. You don't even need an electrician, right? You're literally plugging in a device and then plugging in other devices and then doing some programming and following directions. So you can even avoid and evade any kind of authority having jurisdiction permitting aspect at all. Now, should electricians be worried? No, in my opinion, but also like new technology is new, right? And everyone's got a different threshold of concern or worry about the realities of the product. So you might have, like, these are tested, well-engineered, UL listed. This is not, podunk kind of like garage style, like rigor engineering, right? These are good quality UL listed, tested products. They're new though. They're new to the market. Who knows? I think my opinion, the biggest fear I would have with these is if one of them faults and then NeoCharge has fallen apart as a company, right? And you don't have, right, you can't get it repaired, you can't get it replaced or something like that, right? I think on the technology basis, these things are very sound, but they're new companies and new products. And so if that for whatever reason, that fails and you don't have the backup company supporting the product that you bought, that you're relying on, there's a risk there. But with a $300 item, to me, that risk was worth it. Doesn't seem very high in my opinion, but everyone's gonna have a different estimation of risk. And there's another question here in the chat. I have 3 heat pumps and have never exceeded 16 amps. Yes. And yes, I have 3 small heat pumps, right? They're 3 1-to-1s. They're all on 30 amp breakers. But no, they never I've never crossed 16 amps. And yes, that's because heat pumps don't actually very, very rarely draw max power. Even on that coldest day even at 2 a.m. in January 15th when it's -20 outside and they're going full on. Where you're gonna have high draw with a heat pump is if you've partnered it with an electric resistance backup heater, right? And that'll be existing in ducted heat pumps quite often. And they'll put that in for 2 reasons. One is like emergency backup if your compressor fails. And 2 is during defrost cycles. Heat pumps need to defrost the coils once every couple hours. While they defrost, they take heat out of your house and run it to the outdoor coils to heat up the outdoor coils. They basically they turn into an air conditioner for 20 minutes, where they're stealing heat from the inside and they're dumping it into the outside to melt the coils. During that 20-minute run, they are cooling off your house. And so what a lot of these companies have done is they've put in a strip heat, electric resistance strip heat into the ducting system, so that while it's providing air conditioning, that is getting heated up to be hot. So it doesn't feel like air conditioning. If you can go without that, you can avoid one of the biggest loads when you're doing heat pumps. Was when you have electric resistance backup or electric resistance complement to your heat pump load. But yeah, heat pumps, when they're actually running most of the time, 2 amps, 1 amp, super low. They might spike to higher amperage on startup, but that's not what the NEC calculation cares about or takes into account, because it has to be sustained is the question. I got one from Patricia. Help design.
I have, I think, a comment for Patricia. She's asking about, she's concerned about getting a heat pump water heater because they do cool down the area that they're in, because they're drawing from the surrounding air for heat. And they tend to cool the area around them. But I think someone mentioned when I heard you speak at BS and Beer, Matt, that you can actually pipe sort of a vent to the heat pump directly outside, and it won't, I think it won't draw the warm air from the surrounding.
In our climate, not to the outside. So heat pump water heaters, you can duct a heat pump water heater to get its return air and its supply air and its return air. But if in our climate, you have to do that to somewhere else indoors. So if your worry is about a basement, cooling off the basement, you can run ducting up to the main floor. Right? It'll steal heat from the main floor, heat up the water with it, and dump cold air back into the main floor. And those have to go to the same spot to not create pressure differentials and pressure dynamics. You can't duct that outside. So yeah, that's stealing a little bit of your indoor heat that you're making up with your air source heat pumps, your space heat pumps. It is a vampire load in the winter on your heating, home heating. But all the math and all the studies on this, and there's been dozens in this world, is on net, it's way more efficient, right? Even though like it's a little awkward, like in the middle of the winter, I'm stealing heat from this part that's being heated up by a heat pump, and I'm using this heat pump here to steal heat from that heat pump. But it's fine, right? It's fine. It's fine. You math it out and you're like, yeah, that sucks, but it's way better than being on fossil fuel still. And the overall net impact of that is pretty low on the efficiency, and it's better than doing electric resistance in terms of net impact on kind of loads that you have around. Freezing pipes in a basement is real if you don't have anything down there. Insulate your band joists, especially just that one spot right along that actually has exposure to outside. And then you can put a heat trace, which is like a heat tape. You kind of wrap it around your pipes, puts in just a little bit of heat when the pipes start getting cold to keep them warm from freezing, especially ones that get out towards the corners or the perimeters of the basement. Or put in like a hardwired electric resistance kick heater down there that fires when it gets to 40 degrees. And you'll probably find in most homes, not all homes, depends on the exposure levels and how cold it gets, but even in our climate, that basement doesn't actually drop below 40 except for like once a year, right? And that's when that kick heater turns on. And yeah, that's a big draw and maybe counteracts some of the stuff I'm talking about. But if you have that on a priority list somehow to be when that needs to fire, it gets to fire, and I don't run my stove when that's happening, maybe you can balance that out and do a heap of water here in the basement anyway.
So maybe I'll let Gary Bashline ask his question.
Yes, I'm just wondering, do they make anything like a smart meter, outside meter, service meter?
So the term smart meter has already been dubbed, and that's just for a meter that collects data. They're not actually smart. They don't do anything with that. They just have the ability. So a smart meter in like common parlance in my industry is just a meter that is collecting data on 1 minute intervals, or sometimes they're 15-minute interval data meters, and allowing to use that data to measure power to and from your home or time of use stuff. And those are being installed steadily by utility companies across everywhere, including New Hampshire and Unitil and Liberty territories. I don't know their rollout pace and how well penetration is in our market. There's nothing like a smart meter in terms of managing that draw and then telling or turning off some service in your home or some load before you cross the threshold, right? Because you need to be connected to that and like being able to sort of give a signal to say, I'm hot, please turn this off. That's what the smart panel does, right? But it's the same thing because your meter goes straight to the panel.
Yeah.
Right. So the smart panel does that instead, or a smart circuit in the panel, or the meter caller kind of between the meter caller will turn your meter into one that does that. But you need something that has that two-way communication that can talk to the device it's connected to, read a signal from, or read the power usage and say, pause, hold off, don't do that right now, please, I'm running hot.
So you said it'd be a good idea to put a Sense energy monitor in your house?
I love Sense. I think it's a great product. They're like $150. You can do it yourself. It's just all a Sense does is give you information. It helps you learn what your house is doing and what your loads are. And a lot of people put in Senses and they pull up that, a chart similar to the one that I was showing earlier from my friend's house, and they find something. They're like, oh, whoa, oh, right. Like that seems, fun with kids, like turn things on and off. You could see it going and changing in real time. And you could be sort of, I know a lot of people who have stopped using their hot tubs, right? When they recognize electric powered hot tubs, they're like, oh, that's a much bigger energy draw than I recognize, and a much bigger portion of my bill than my electric bill than I realize. And I don't actually use it that much. So maybe I'm going to live life without it, or only fire it up for like when I have visitors in town. And obviously you got to fire those up like a day ahead of time to let them heat up all the way, but like, manage it in a way. So Sense is great for learning so that you can make choices to manage your energy use intelligently.
Okay, thank you.
Just to say something about that, I think Sense costs about $300.
Is it that much now? Okay.
Yeah, but I think there's
Inflation happened.
another brand, Emporia, that you can get a smaller version for 150. And then there's one for $200, the Emporia. Yeah.
There's even like this thing called a kilowatt. You plug it in, and this kilowatt doesn't measure, it like measures like one exact load. They're great. You can meter how much. They're like 35 or $40. Buy them on Amazon or anywhere like that, and you plug it in. You're like, how much is my entertainment system actually pulling? How much is my fridge actually pulling? How much is my right? And it goes into a normal plug, and you plug through it. They're great little products. They can help you.
Yeah, and
again.
many libraries have those that they can loan
Yeah,
out.
to loan.
But
Yep.
those are only for 120 volt.
Yes,
loads,
120 volt single loads.
not for dryers or electric stoves or stuff like that.
All right, we have Bill Stearns with a hand up. Oh, who disappeared? Right when I called him.
Guilty as charged. There we go. Sorry.
There he is.
Let's try that again. Thanks for the presentation. Can a Tesla Powerwall or another battery system be programmed to pull load when other devices are not using as much power, and then use the battery pack to run a heat pump or something else that needs to run all day long?
So most of those Powerwall, like most of those home battery systems, their default setting is fully charged, right? So they'll pull load when your house is calm and quiet until they get to full charge. And then they'll use that charge in the way that you determine. So for some, that's like a bring your own battery program. They discharge back to the grid for benefit. I'm in that in Green Mountain Power system. Sometimes that's when you have a power outage in a storm to cover everything. And then some of that, yeah, you can give it, you can tell it to go to certain, I believe, this is what I was talking about earlier, and I guess I don't want to talk out of turn. I don't know well enough. I don't believe they've done enough of the software work to like talk to individual loads from your panel. I don't think there's a communication pathway. The gentleman earlier has his connecting to a sub panel and controlling all the loads on that sub panel of critical loads. And so it can be programmed to like send power to there to cover those. And maybe the other loads can be told to calm down or stop drawing during that period.
Thank you.
And that combination kind of does it a little bit manually.
Great.
And we have a hand up from Nathan Goldstein.
Yeah, thanks so much, Matthew. This is such a great presentation. I'm so grateful to you for this. I want to get to something you said earlier. I'm also finding that when we call electricians, they have no idea, and they're like, "You just need more power to the house," right?
Yeah.
Do you have suggestions on how one finds electricians that know this and will be able to answer these questions? And we've had 3 electricians, not a single one who's actually figured out the math and just been like, oh, well, you need more electricity. How do you
Yeah.
find electricians who know, who can actually do this detailed work?
I have no idea. I hope that the work that I'm doing contributes to a information sphere that brings some along, right? Like one of my deliverables from this demonstration pilot is to build a document to convince AHJs, authorities having jurisdiction, and to convince electricians that this is real and work with them and train them on it. I know like companies like Span, they're trying to spread out. So that's one thing you could do is like if you're gonna work through a company like Span or NeoCharge to buy one of these products is talk to them and use their electricians. Sometimes that's at a super premium. And sometimes like I tried to use that with NeoCharge. They connected me to this sort of electrician consortium called Treehouse. And they gave me a quote that was just off the charts. There's no one local. So unfortunately, we're kind of in like an ecosystem right now where electricians are hard to find time with at all, and knowledgeable electricians on this stuff is super rare right now, and I don't have a solution to that.
Yes, Chad Tribu put in the chat that there are 3 electricians attending this presentation. I'm one of them. Chad Tribu is another, and Greg Hans is a third. And I am so grateful to Matt for doing this. So this stuff is new to me, but I'm all in favor of using these things. I haven't used any of these yet, but I'm very open to, I really wish I encourage my customers, not to do the service upgrade if they can work with this stuff. So I don't know if Chad and Greg are willing to put their emails or their contact info in the chat. And I think everyone here has my email address from all the promotion I did.
And I hope I didn't come off as rude to electricians. I love electricians. We need so many more electricians, and I'm so glad here we go. We have some that are like, and electricians as a profession, right? The entire job here is don't burn down houses, right? That's apply a lot of knowledge and don't burn down houses. And so there's a very good, solid reason why there's a risk aversity there, and why there's sort of, let's, be so, but they're learning. They're starting, they're recognizing the electrification revolution that's going on around us, and some are jumping right in whole hog to say like, I'm going to learn about all this new stuff coming out so I can be that supplier and provide those services myself.
I was not offended at all by anything you've said.
Oh, good.
But yes, I mean, fire safety, this is a terrific, these are terrific tools to prevent fire hazards. So I don't know if what other questions there were on the chat.
The chat seems to have either been anything that was written was also then some people asked with hand raised as well. So I think we're through everything in the chat, other than these last ones coming through. And then a new hand from Janet.
I don't know if this is related, but let me ask. I am thinking about putting in a heat pump hot water heater. I have 2 hot water heaters. I have an apartment in the garage and the main house. The main house hot water heater is is powered by oil off of the furnace. The one in the garage is an electric one and keeps making hydrogen sulfide because I have iron and magnesium in my water, and even with the water softener, it doesn't help. I've burned out one anode already, and after less than a year with a new, very expensive water heater, it's starting to smell like sulfur again. Will a heat pump hot water heater do the same thing as in a direct?
No.
No.
Yeah, because that one, the heat is coming there. There'll be a coil that flows into it, but instead of electricity coming in, it's just sending in hot refrigerant inside that copper coil.
Oh, cool.
Right.
Okay.
So it draws heat out, it compresses that heat in, it draws heat out from the air, warms up refrigerant, which is just a fancy chemical, and then it compresses that into a concentrated, just like a pressure cooker, squishes that heat into a smaller volume, makes it hotter, and then runs that hot refrigerant through the water, like contained inside copper, right? And then the heat just dissipates out and then goes in cycles again. So those won't burn out anodes, those won't have any issues there. Now, for a small apartment, you might want to consider the 120 volt ones. They'll be, lower draw, but but a full 240 volt small 50-gallon heat pump water heater could do great there.
Okay, great. But I would, not being a plumber or anywhere close to that, I'd still need to have the 2 hot water heaters, because to send hot water from the house through this conduit under the driveway to the apartment would be kind of crazy, right?
That would be tricky to pull off. You probably need, yeah. I mean, it's
Okay.
doable, right? Anything's doable. You can move hot water with pipes, but you need to have it well insulated. You need to have pumps, right? It would take a long time for that hot water draw to get there if the tank that's storing it is all the way in your house. I don't know the exact situation, but my gut on yours is
Okay.
it's best to keep those two separate. Yeah.
Okay. And you said the heat pump hot water heater needs to be in a place that's more than 40 degrees, right?
Yeah.
And how much space does the heater and the heat pump, I mean, does the heat pump take any more space than the water heater?
It's slightly bigger, so it's attached to it. So it looks like those tall tanks. It's just got a little bigger blob on the top that has the heat pump itself.
I've got plenty of vertical space.
You got plenty of vertical. It sits there. It needs about 700 cubic feet of makeup air around it. It can't be in a small closet, because basically that turns that closet into a refrigerator. You'll cool off the closet itself very, very quickly. So if it's in a closet and you have that, you can put louvers in top and bottom so that the air can flow in and out of there. You can duct it in and out of there into the conditioned space, into and out of. Again, you want to maintain that pressure difference. So there's ways of tricking that out as well. The other option is a split heat pump. So Sanco 2 has these as the company, or Sanden. I guess they're called Sanco 2 now. They changed their name at some point. I can never remember what they are, but they have one where it's split. So they have a unit outside that looks like a heat pump space heater unit, like kind of that suitcase style, kind of rectangular, mounted on the wall or on the ground. And then it creates hot water out there using CO2 refrigerant, cold climate capable. They run all the way down to -15 or something. And then it runs hot water into a storage tank inside. So that one absolves any of the need of fresh air makeup inside. Now, I don't know contractors around here that know Sanco, but that's the other option that we see in this space.
Okay. Good to know. I have some options.
Yeah.
There's a chat question. That Unitil offers a free sensor to screen for electrical fires. And can you speak to these? I don't know anything about them.
Yeah, I've never heard of these, but I'm curious now what they're measuring and how they're metering it. I'm assuming that they're curious if they're looking circuit level, if they're looking
I know.
at the main line. I mean, the main thing that stops electrical fires is your breakers,
Yeah,
right? And depending on you might have old infrastructure, you might have old knob and tube, you might have old like aluminum wiring connections, you might have other things going on, or a fuse panel rather than a breaker panel. In older homes, there's all sorts of old stuff out there that I didn't get into here. And
yeah,
some of
and there
those
are,
are higher risk for fire, and
and
you
there
probably
are
just want to
arc fault
modernize.
breakers, which
Yeah,
will
arc fault
detect,
breakers.
they will detect any arc or spark anywhere in
Yeah.
a circuit, theoretically. When they're very good fire safety devices. I have a question for you, Matt. You
Yes.
mentioned that you could, can you actually put individual smart breakers in like a regular breaker
Yeah.
panel?
Yeah.
Wow.
So a bunch of those companies, I listed them. Let's see, let's go back to them. Smart breakers. Leviton, Eaton, Toyota, Schneider, Siemens, and others all have smart breakers available. They're more expensive than your standard breaker. They
Right.
basically do the thing that I'm talking about, right? Where they're metering energy and they're saying, hold your horses, don't go right now if I'm running hot broadly. But those go in, they take up a slot in your regular, regular panel like this, right? Not a fuse box, not one of the
Right.
other ones we were
Right.
talking about, but like a sort of standard breaker panel. Yeah. And they will connect, just take up one of these slots and connect to one of your things in your house. You can put two of them in, put three of them in. Yeah.
That's great. That is great. Okay, maybe we have we come to the end of the questions.
All right.
Matt, thank you so much. I think this is such important and very useful information, and I'm so grateful to you for doing this and for doing the presentation for us. For doing this work is really, really important.
My pleasure. Thanks
And
for having me.
Our pleasure. And will you be willing to share your slides?
Yeah. I'll turn this into a PDF and send it your way.
Wonderful.
That'll
And
make it easier to email because PowerPoints are big.
that would be wonderful. And I will send that out to all the registrants, people who have registered, and I will, the recording will be available. It takes me a couple days to download it and put it up on YouTube, but I will send people the link as soon as it's available. And thank you again, Matt. Really, really appreciate your time and all your work. And thanks for everybody for attending, and I hope you will share this information with other people because it's really, really useful. All right. Good night, everyone.
Good night.